Good morning. Looks like we're live. All right. So we're going to start today, as we start all days, with a brand new project, cas3. We do this because the repetition is very helpful for me in teaching and explaining, and it's nice. So this time we're going to copy some stuff over for expediency, obviously. And we're going to progressively do more and more of that. But basically, the first thing, we're going to get a parser because it was super annoying to just mangle lots of expressions, and I just want to give it strings and whatnot. So here's what we're going to do. We're going to say C add peg. And so that's our parser, and I'm just going to come and yoink that. And it's just this simple thing. There. And I don't think I need this. I don't think I need that yet. Okay, so now, remember, so this is just a parser for our expert, and our expert has the most basic struct. It's just a tree of strings. So we can have a symbol, and that's our atoms of the language. And then we're going to have a compound expression, which is a list, which takes a vec of expert. Okay. Then we're going to just copy in some handy, useful functions. So I'll just explain what these are. This is just an easy thing that gives me a sim from a string, and it's just useful for inline comparison and checking if the head of something is a string. Oh yes, of course, we need to be able to do derive, debug, clone, partial eq, hash. Okay, so now we can do lots of things with this. This returns either the name of an atom or the first element of a compound expression, because that's how we do things in symbolic languages. Is basically we have this list structure and the operation, so the head of fx goes to f, and the head of f goes to sim. So we get basically that this, okay, then what we wanted to do is we wanted to write, we're going to need this function. This is a function that helps in checking if a blank matches an expression, and it just has this one caveat that if this blank h, we check that if it has an argument here, that we check that whatever we're matching against matches with the head of expert, and we need to flip that around. Okay, easy stuff. All right, yeah, I'm gonna want these functions too. These are nice to have. So these are functions for rebuilding expressions given hash maps. So basically, as we traverse the tree and look for patterns that match, we're going to be inserting into our map, and we're going to do that in the pattern matcher. And let's see, why is this? Oh, interesting. I don't remember writing pub there, but yes, we do actually need to make this a pub so that the parser can see it too. But here, I think we can just remove this. I don't really know. Okay, so now it's time to write the pattern matcher. And we did this last time, but only with one blank type. But now, the crucial thing that we're going to be doing this time is we are going to be introducing these two guys. So this is blank sequence and this is blank null sequence, and they match any sequence of one or more expression, any sequence of zero or more expression, and then we can have it with names, we can have it with heads. So this is basically what I think is the most important section of the pattern matcher, and unfortunately we don't have this. But I don't think that would be that hard to find, to implement. Okay, so I have a old version of this pattern matcher that has blank sequence support. But it's super long and super messy, so we're going to rewrite it, and we're going to see what happens. All right, so cas3, let's go. And then I guess we should probably get these test cases. They're so messy though, I don't like. But no, they're essential. Alright, so just see, alright, we don't have match, so we need to make sure that this works. Okay, so now we're gonna write my match. It takes an type expert, takes a pat type expert, and it also takes a pos, which is a vec of view size. So where are we in the tree, in the expression tree? And then it takes a pos map. It takes a pos map, and this needs to be mutable because we are going to be inserting into it. And then it takes a named map, and it returns a boolean. Okay, cool. So now what do we need to do? Well, we need to match on xpat, and I forget. I'm just going to clone everywhere I can, and then we're going to optimize later, because that's one of the annoying things. Okay, so first we're going to do expr sim e expr sim p goes to e is equal to p. That's the simplest case. We've done that 3 times now. If that's not burned into your brain, then okay, wait, let's set this goes to false, so all the other ones. Then we want expr list sim e expr list p's. What we want to say is so the correct behavior here is so we want to check if the head is either pattern or blank, because that will capture. And we also need to do oh, and we need to make this actually okay. So that seems about right. And then else we return false. Okay, so we have this function up here, which I'm going to put the rebuilding stuff elsewhere because I want to look at this function. I got water on my keyboard, on my mouse. Okay, so so I think that these can all be. I can't think of a case where these don't all just get merged into. So what we could do is I think that we can do this, but we're gonna see. Else if blank sim stuff contains ps0. Okay. So here we want to say if is blank match E is going to be X and P is going to be is it 2 or 1? Maybe 2. So if this is a blank match, then we need to insert, and we're going to insert that, and we're going to give it X. But first, actually, we need to check if let sum equal to, let me just mark this up right now, named map get pointer to cat. Then we need to return, then we need to give v equal to x. And I want to remember, it may be the case that we actually recurse here, but I don't really think so. Okay, so that's cool. Else, and we probably need to make it can't compare pointer. Okay, cool. So if we see a pattern, if we see a pattern head, then we know that there's a name there. So we get this, and we're storing in our hash map, we're actually storing the whole pattern object just because, I don't know, it's easy. It's nice. Need to borrow. Okay, so now if, so this means, and then pos map dot insert, we can assume that there is no or assert Rust how to assert that a hash map does not have a key. Okay. Or if we have, we remove the key of pro. Yeah. Bottle. Okay, so then we insert pos if with expr. Or what do we call it? X? Okay. And we say true. Right, I need to switch the order around because I used to do this. And then rebuild all we need to, well, I don't really care about those are all details. What's going on here? Okay. I mean, these really need to take pointers. It's pretty ridiculous. Should I just make that change? I don't care. Okay, cool. So now we have this is the pretty good logic for what needs to happen when we see a symbol and we're trying to match it to a list. If it's some pattern object, then we do all the pattern logic. Otherwise, we just return false. So that's pretty simple. Now we have x per list e's, x per list p's. And we have to, now this is very important to get right. So now we have no guarantee about the length because the blank sequence and blank null sequence objects, these, which okay. Oh, we also need to do or well, we haven't recursed yet, so that's okay. Okay, so the first thing that we need to do is we still need to check all of this logic. This logic all stays the same. The only difference being that we don't return false. Okay, so if we are not in the else branch, we are matching the entire x list x. Okay, but if it's not, then first we need to say let p head equal to ps1 or 0. Let e equal. Okay, and now we want to call. Now we want to recurse, so we want to say that new pos equal pos clone. And that's going to be 0. And remember, pos always refers to the place in the pattern, not the expert. Okay, then if we probably have to clone. Now we need to be careful about removals. So, but we still need to give the pos map and the named map. But I think we want to try to do. But is that removals are going to be weird? I don't know if I need to remove like this. Okay. Okay, so let's say like right now we're gonna recurse because we have fx matching with f blank. So we go into here and we're matching the head. And if these don't match, then we just need to return false. So the heads don't match, then all bets are off, I think. We need to keep going. Okay, so then I want to cheat a little bit because I want to look at exactly what I have here. Okay, so we're in the list arm, and then we match on the p head. We end up just doing this, so we don't actually need to match on this. But here is where we do this. Oh, I think that this is that true? No, because this is sort of like the base case. This is the base case for when this is like a list without nesting, like it's just a pattern object at the top. And so even in that case, it does not matter. We can probably merge these two arms, but we'll figure it out. Okay, so I think we have up until here. Okay, so yeah, so we just start writing our loop. So for I, pi in he's dot wait, but how does skip work with enumerate? No, it probably we skip the head. Remember, blank sequence and blank null seq can only match what am I trying to say? Like, given FAB matching. And I'm going to good stuff. Okay, so now what do we need to do? Let's see if this works. But to the end here, alright, I'm curious if I just copy this in. Oh, everything is probably named wrong. Alright, I'm not going to do that. This as list stuff so nasty. Nasty. Oh, we also need the flatten sequence function. Where is that at? I hope we're not relying on anything that's cool. Okay. I'll make a function rebuild and splice. Just does just call splice sequences of rebuild all. Okay. So so what is it that we're doing here? look at the head. Okay, yeah, fine. Then we need to, we need to do this. Well, actually, yeah, it's true. We need to do a P type. I probably can't index this though. And we can match PI. I feel like that's not that great. Okay, I don't know what the hesitancy is here. I feel like I should just copy stuff. Problem is, it gets overwhelming. Okay, fine. Let's do that. Match PI. No, we could just add that condition in. I kind of like that idea. We build and splice. We give it pat. Why isn't it formatting? Wait, let's comment this out. Okay, so what this is saying is too big. I was gonna do this. Just gonna make it a little bit bigger, but then I'm also like a little bit out of the way. Go all the way up there. My head's cut up a little. Okay. What's up with this? I got a clone. Gotta borrow. Yeah. Okay. If we've reached the end of matching of it, the list, pattern list, finding mappings for all elements, then we should be able to recreate X from Okay, so that sounds pretty good. Oh, we can now just do this. Is it 2 though? This is B, right? That's gonna be B. But now, this is the case where it matters whether we are dealing with it is nice to have that deref for this. Damn, because then you don't have to keep matching. Okay, well, let's think about it. Oops. Okay. Okay, so is that deref stuff in here? Oh, we could add the formatting stuff too. I don't know how useful that is. Okay, so what exactly does this do? So this allows us to index into a thing. think we can just do this. Okay, so now we should be able to be down here. And we should be able to say, we should be able to implicitly make the assumption that these are that this is a list. So I should be able to go like this. 0 let pi blank h equal pi ps. Oh, hold on. What's up?
I'm mad that Katie tried to bite me.
What?
I'm mad at Katie. She tried to bite me.
Oh yeah, what happened?
Begging to be pet.
Wait, I can't hear you. All right. Nope. Oh yeah, are we doing head matching? Yeah, we are. Okay, so what is happening here? We got this deref thing, which I don't know if I like. Okay, this is guaranteed to be there though. So if we just call this blank t. Okay, so I'll put a thing in here. Then I do want to copy all of this code. Okay, there we go. To ease, we could just do that. I don't know. It's just printing. Some for name. Wait, what was that? erest k. Okay, I'm done for that. Okay. We don't need this. Oh, okay. Yeah, I think that's fine. I think so, what I was worried about is if I somehow need to, but sequences handle that for me. So sequences is how we get around the idea that there can be multiple experts. So, oh. But hold on, I thought of a better way to do this. Can't I just call? Expected mutable row found slice. Dot as mute dot to vec. So can I just do this? Okay, so I think that this go away. And here we just need to say, oh, list of else? Is it list E of else? Okay. Okay, so where's this pos stuff? Pos. Okay, it's equal to pos.clone, and then we push I. Wait. Yeah. So then we give it pos map, named map, my match. Oh, yeah. But presumably we actually, since we're already in the pattern thing, we shouldn't have to do anything with positions. So maybe that's sort of premature. I think it might be. Okay, so where are we at here? I guess we could actually just do what does that even mean? Yeah, I don't really get what it's telling me to do. It needs to be in the No, that doesn't change anything. I thought maybe because it was up here. I have no idea. Hmm. Okay, I guess we could see if everything blows up. This doesn't seem right. Does 2vec clone it? Oh, okay. I guess it's okay. Okay. So let's just write a test case to see if um, there you go. Oh, I need to do pattern X blank C. 1, 2, 3. Hmm. Hmm. Um. Um. Did I still call it new pos 2? No. What's wrong with this? Can I remove the... Oh. Right. Beautiful. That's awesome. Let's see what happens if we do two of them. Let's do this. Y. That is very nice. We are getting somewhere with this thing. So the end we get x goes to A and y goes to BC. That's perfect. That's exactly what we want. Try something with nesting. It's pretty good. Then you do this. And this should be literally the exact same code. Except we go from 0. Nice. So this is already pretty good. Now, what's a case where it needs to backtrack to remove something? Let's try a trustee. No, that works pretty good. Yeah. So here, what do we need to do? Are we supposed to return true there? I thought maybe we're supposed to break. I'm gonna try to remove this and do break. Oh, but we need to break out of both? Okay, well, never mind. Okay. What do I have in the blank here? I say okay, yeah, we try to match the ith one. Head equals pattern, else head equals blank. Oh, here. Alright, I'm gonna copy this in. And just delete a bunch of it. Or no, I'm not. I think we can copy. And it's gonna be Interestingly, we're not recursing there. I feel like we should just recurse. But fine, I think that does the exact same thing. Oh, I see. Right, so first we want to do this. We EI, PI. We're going to need a day where we go through and we finally convert to RC. Okay. So we just try to match those. And that can insert, or that will insert if it doesn't already, right. So it'll do this logic where it does the name map.get. Okay, cool. So now what can we do? We can do a blank, a named blank. Of course. Do we call is? Let's do another one here. Where we have A, B, A, C, B, D. Now, Yeah. So why is that? So here we're getting that x goes to, it takes BD. But we need to check. Do we do it in here? I think we might. So we need to go back to the for loop? Yeah. So what are we at here? I should look at my test cases from here. Let's see. No, that one we got, which is great. This should go here. Then we get into this. It is this case, right? Okay. So there's a bug in recursing. I think we need the length check thing. Because if the pattern length is greater than the... No, that's still not true. Because you could have triple blanks. Oh, it didn't print anything. Huh. You'd think it prints something. Hmm. I think if this fails, you return false too. Let's try again. Okay, so that worked. Not anymore, bucko. And let's make sure that this is true. It's time. We need this. Then we're gonna remove Okay, so we're getting kind of close. With a pointer to sim blank C. Then we need to say let blank t equal or no, then we know the blank t, and we just need the h. Cool. So all we need to say here, we need to copy this and just do it positionally, I think. Get okay, so let's see if that works. We're gonna have a test case A, B, C, D. We're gonna have blank seek and name blank seek. Right. Cool. We need to make heads work. Wow, is today the day that we actually finally get this into cas3? Alright, so let's just try to do this. Let's finish from 0. I think that's literally it. Alright, let's make sure. Oh, we do need an else case. You want me to move it? I'll move it, bro. Where should I move it? Should I make it smaller? Here, I'll move it here. Thanks, bro. That's good looking out. Thanks, Doug. Yeah, I feel you. How's this? I feel like this is better. What does that mean? What does that even mean? What do you mean? Oh, yeah, I can put it at the bottom, but what do you mean frame? So where are we at here? We need an else case. An else. What are we doing? Like a different scene for a cam when it's wrapped into some kind of outliner. Does that mean like have a background? Because I found this thing called, what is it? OBS background removal. So I didn't want the background because otherwise the background like hides the code. So I wanted that. So I wanted people to be able to read the code. If there's a video on how to do it or whatever you're asking, I'll do it. I don't really. Yeah, no, yeah, you're right. The removal isn't great, but here, let me show you what it looks like otherwise. I gotta go to filters. I gotta turn this off. The problem is then so much of the code gets blocked. Yeah, no, I know what it looks like. I watched the VODs. But here it just gets so much of the code is blocked that I feel like it's better than nothing. I prefer it. I think it's maybe it's a little disorienting though. I go back and forth. Cut the ratio. Let's see, what settings do we have in here? Even this thing, it doesn't really help. Let's see, smooth silhouette. This doesn't really change anything. Let's see. I do have a GeForce card, so that's not the worst idea. Let's see how it works. Can I use it with OBS? Let's see. Yeah, so it shows up as a new camera. That's kind of cool. That's pretty good. Wow. Yeah, you might have put me on something cool. All right, I'll play around with that off stream, I think. But that looks good, dude. You might be onto something, bro. I'm losing arms. Yeah, sometimes when I'm drinking coffee, I just completely disappear.
So let's say you wanted to add a camera frame.
This is pretty good, dude. I'm glad you put me onto this. I'm gonna keep a note on this because yeah, man, because that looks way better than what I have. All right, for right now, I don't want to do that because I'm just like right in the middle of something. But dude, I appreciate it. Did I change this? Let's set the defaults. Okay. Kappa. Yeah, it's cool though because this is open source. That's why I like it. Like, part of the issue is that the NVIDIA one, I feel like it's probably just harvesting me for training data. So I'm not like super thrilled about that. But yeah, I'll try the bottom right because I feel like usually my terminal is more empty than the code. So this is probably a good suggestion regardless. Okay, so where are we at? We need to do this. This is the case where one of the PIs is a list, but not a... I think we just want to do this. Let's try that. Okay, so this is... No, wait, but that's supposed to... Will that return true? Wait, hold on. Test case 8. I wish we had a better way of doing this. Let's see, what is typist? I'm guessing not. No, not at all, actually. It's, what it is I'm actually trying to recreate Mathematica. So Mathematica is like a super cool way, it's like an interpreted language, but it's all based on the idea of pattern matching. So what we're doing is we're building the pattern matcher to have, so in past streams, I started and I made pattern matchers that use these first two pattern object types. But now we're extending them to this more regex-like thing where basically we can have pattern objects that take, one or more or zero or more expressions that they capture. And so it makes the algorithm a little bit more complicated. I've been working on it for like a week now. So it's not like typist, although I did hear a lot of buzz about typist. But I haven't messed around with this at all. But yeah, no, totally different thing. This is a programming language. And so the real repo for it, in case you're curious, which does work, it just doesn't work with pattern variables, is cas3.rs, which I'll drop in the chat, in case you want to look at it. I think it's the best somewhat complete Mathematica out there. You should be able to just cargo run it. The build is kind of annoying because I added this dependency for arbitrary precision integers called rug. I think I might need to figure out how to make the compile time a little bit better. I remember the typist included a subset format, like syntax for writing formulas. Yeah. I'm sure they have lots of shared code. Yeah, do you write Rust code? Because you just linked the Rust project. Or do you code at all? Oh, nice. What's your GitHub? Drop it. I'll shoot you a follow. What do you write? What do you code? Six, 7, 8. This one? No, wait, this is 8. The thing I work on didn't push anything last month, but I have some progress. Let's look. Oh, wait, okay. From Poland. Ethical web scraping. Oh, that's interesting, dude. That's cool, man. Is this you? Ole. I can't even follow you. Damn. This is sick. Dude, web scraping is so cool. So are you trying to like make like a common crawl? Dude, I love common crawl. Like a... let's see. 80%, 82% of raw tokens. I bet this isn't even... Well, maybe that's true. That's cool. Ethical web scraping. Okay, so what was going on? So this returns true. Yeah, that definitely should not return true. More generic. It's more of a tower utilities for data retrieval in an ethical way. Huh. Data retrieval in an ethical way. What does that mean? Like, what's unethical data retrieval? Okay, so we need to see. In this case, we just get a sim, so we shouldn't even go into this arm. We get a list. We get a pair. Else if it contains this. Assert does not contain it. Oh, we still need to put this in here. And move this here. Move this. Move that. And then I think, is this supposed to be X? Yeah, this will be X. And this will be PS2, right? No, it should be. It should just be should just be Pat. Alright, let's try it again. Okay, getting farther. Okay, so now we're in the list case. And we're here. Oh, we just need to do the same thing. Is that for work or is that just for, let's see. Oh yeah, that's so interesting, dude. Because I actually, so I was working on this thing. Rate limits are so interesting. So you don't DDoS the resource. Access something that should not be included. Deduplication queues. I don't know what that is. Depth limits, you only get to 3 levels of website. Yeah. Yeah. That's cool. Yeah, definitely the DDoS part is sweet. What was I doing? Oh yeah, because, well, yeah, that's super neat. Where's the rate limiting stuff, or have you not pushed it? Because I would love to look at that. That sounds cool. Not yet. Yeah. Yeah. Yeah, I haven't pushed in a minute either. I feel like pushing all the time is obviously better, but sometimes you're lazy. Like sometimes I'm just lazy. I don't want to do it. Okay, so here per resource and global dynamic rates. Cool. What's a good like website that you test against? Or do you have your own infrastructure to like set up tests to make sure that you actually follow the rules? Yeah, I would love to look at that code. That sounds interesting, dude. All recipes. Oh, interesting. You actually use this? Huh. They have an API? Oh, nice. That's hilarious. Yeah, we need every recipe right now. Yeah, no, yeah. I just thought that's a funny one. Okay, so we need to. So we can assume the insert. I think we can just copy this. But one thing. Uh. here, the position should be right, but in here, the position actually needs to be 0. Okay. So let's do this. But we need to, we're going to actually move this to right here. So for the purposes of this whole thing, we're doing head matching. And we don't want to return here unless we get false. But we do want to insert our die. And then we want this to be new pos. How long have you been working on that? I'm curious. What is X? Oh, is XW, is this? Yeah. Yeah, I feel that. I'm really bad about making libraries, like, especially stuff where you get it to a point where it's like good enough to release and then you know to not make breaking changes. I feel like I'm super disrespectful of that and I just do lots of breaking changes. Yeah, I totally feel that. I was stalling on this for like a crazy long time, and now I'm just like, at some point I gotta do it. Ooh, I'm sus of this logic now. Well, if the very head is pattern, then these can all be returns. So I want to be explicit about the returns now in the list on. I'm pretty sure that this is all good. Then we only want to return the Alright, so we do want to return true here because if the head is a pattern object, then we're matching the entire list. But then otherwise we do our iteration thing. Okay, so let's see if we've handled more cases now. Uh-oh. Somehow we went backwards a step. We broke something. So now 1 and blank. Why is that not working? Okay. Wait, what? Oh, interesting. Okay, so for the inserts, I want to add our print statements. So inserting on I kind of want Copilot back. Whatever. Oh, I think I just do this. Oh. Uh, if it's at the head, then it's a whole thing. So we actually want just pos. Oh, sweet. We got all of the cases matching. Sick. So we just need to add heads. Is peg leg nom? Yeah, except I think it's a what's it called? Yeah, it's like nom. It's a parser generator. Yeah, what's yak again? Yeah, another uh whoa, it's made by Steven Johnson, dude? Wait, is this the same Steven Johnson? I feel like this is a different Steven Johnson. Busy working on I feel like this is not this is what you're supposed to write in Wikipedia. Yeah, here, let me give a brief. This is like the simplest parser. I mean, I don't know why I didn't pick nom. I remember that I tried a couple of them with GPT just generating my rules, and this one seemed like the simplest possible thing because all I have is an S expression parser. Here, let me give a little demo of cas3. That's all right. But I have a little REPL. Why not? Let's open up cas3. So in cas3, I have a little REPL where I can put S expressions into, and I have a little evaluator, like a Mathematica evaluator here. So cr-release. Cool. So now I should be able to say set x to 1, set x to 2, x, stuff like this, plus x5, 7, do I have factorial? Back 1,000. Give me a big number. You have a bit of nom. Let's look at it. Let me look at nom because I remember like I don't know my thought process is like parsing is not for me the most interesting part of my project at the moment, so I didn't really care. But let's see. Yeah, I thought this was lower level, like at a token level. But let's see. Where do I find all the nom related stuff? Oh, here we go. Yeah, this seemed like a little bit more overhead than I want, but maybe it's just because I'm not used to it. Let's find all the nom related things. I remember I tried to use it, and it was just like let me look at their examples. They have a JSON. God damn. Oh, yeah, I saw the lifetimes. I was like, oh, geez. I'm sure it's probably more performant than whatever I've got going on. Oh, here, S expression. That's perfect. Damn. See, that's what this is like 400 lines. It's like 10 lines of code. I love it. Let's see. For some reason, nest f x 10 or 1,000. Let's see. Does that work? Oh, that's slow as hell. That's brutal. Why is that so slow? Damn, dude. I do not like that at all. We're gonna have to optimize the hell out of this thing. That sucks. Gets exponentially slower. That's brutal. I don't like that at all. That's very upsetting to me. We're gonna have to figure out. It's probably because we don't do reference counting, so we're storing tons and tons and tons of copies of the expressions. So that's probably what it is. Yeah, yeah. But if you look at like what internals reference, yeah. So here they give an indication that basically the way that they manage memory in the system is with reference counting. So I think if I just made all my expressions do that, then all my clones would just be copying a pointer instead of the entire expression. So I think that would resolve that issue. But the whole point of this project is, where can I do it? I think it's just using standard RC. What is it called? Use RC. I think it's that. And then I just make my expression type RCs of all those and I pass around. Yeah, I can replace it. I can switch it later. But for right now, performance isn't my main goal. But I guess this is showing me that performance is definitely going to be an actual bottleneck. My goal is that I want to recreate the I want to recreate all the systems in this chapter. So cellular automata, maybe mobile automata, definitely Turing machines, substitution systems. And then one of the most important ones for me is combinators, because I feel like combinators are sick. Where are combinators? So I can do stuff like this. But right now, you kind of can do stuff. Oops. So I kind of can do like kx, y. I can do replace repeated kx, y, c rules, and I'll get x. And I should be able to do this. But for some reason, nest of S10. Yeah, why doesn't that work, man? That bothers the hell out of me. For some reason, there's a bug in the evaluator. Like, we don't end up evaluating this, but I don't know why. Because I think if I copy and paste this in, does it self-evaluate? So it doesn't find anything to simplify down, but that's just wrong. You want to contribute, dude? Yeah, man. I feel like, so there's one more project called Mathx3. Mathx3 is probably the more complete version of of what I'm trying to do, but it's written in Python and it's like, I don't know. For me, first, I couldn't even get it installed. There was some bugs with installing the thing for me, which is unfortunate. But I wanted to build my own just so I really understood it. I would say the best thing to do is to, if you can get onto Wolfram Cloud, if you have like an EDU account or something, just test things out. Like I just have this notebook where I just test out how the pattern matcher works, and then I try to make sure that it works in here. And then I feel like this is like one of the coolest projects you could do because it's like when you implement a programming language, you implement a programming language in another programming language, or like assembly, whatever. But here, the amount that you do on the host language side is super minimal. Like you bootstrap with as little as possible. Like for example, in cas3, if we look at our built-ins, internal functions apply. We basically just do, we just have this huge switch statement where we look at the head and we just, so here is set. So this is how set works. It's kind of messy. Here's how plus works. Here's array indexing. And so there's like super few primitives that I feel like I need to implement in the host language that like talk to the kernel. Why don't I? So that's a good question. I could do that, but the whole point of Mathematica is that you have this insane flexibility that there's no difference between any old symbol that you put into the system yourself and these special symbols. So I could, and then the parser could like see that, but there's some cool beauty to having an expression type that like literally only has 5 things in it. So like for instance, head of head is symbol. Head of my expert is symbol. So it's kind of cool to me that, because otherwise what we would do is then in our head function, we could just make like expert, what is one of these built-in functions, like set. And it's like a thing, and it it reports that the name of its head is sim, but I feel like that would clutter a lot of the elegance of our expression type, where you just have symbols, a few atoms, and then a compound expression type. But I have gone back and forth on that, and I actually, yeah, there's let's see, that long if else is definitely scary, that's for sure. Wouldn't it make it, here, wait, actually I should probably do this so that the VOD will have this. That long if else is kind of scary. Wouldn't it make it possible to optimize transform? What do you mean? I don't get the second part of that. But yeah, so one thing that's really cool is that like if you do head of A, B, head can take 2 arguments. So one thing that's really cool is their parser, they must have some way of registering or telling a registered built-in basically constraints on the number of arguments that it can take, and so then it turns it red. So I was thinking that it might be cool to have some framework to register built-in functions, and I could split all of these into their own function. That's totally fine. Yeah, I need to see how that would work. So what he said was, if you were to parse them as tokens, you could recognize patterns of token sequences. Could you give me an example, like an S expression example? So you're saying like, yeah, we need an example to talk about. If you parse them as tokens, you could recognize patterns of token sequences. Hold on, I'm beaving it back in a second. But I agree, this is like the most sort of nasty part of the entire code base. It's just like 200 lines or something of like me hacking together something random. Okay, so where are we at here? So all our test cases passed, so that's beautiful. We just need to now add the check here. Where? So now what we want to do is we want to say, we actually want to, or we just want to add a thing that, so we want to do else dot push seek e or let me read your comments. To make it easier, as you could import debug for token enum. I don't really understand what you're saying though. Like, I needed an example of an expression that would make it easier to debug. Right now I derive debug though. Oh, scary math times 0 equals 0. Oh, but that's the cool thing about that is that it doesn't matter, because what you would do is you would use pattern matching to write that identity. So it doesn't even matter because I can already do that in cas3. So if we have cas3 up here, I could say set times blank 0 to 0. And here, let's do this. My times. Then my times of anything else of pattern A blank, pattern B blank returns capital times, which is the actual thing. I think, let's see, do we get our things right here? So we need this one here. Set my times of this with the times they use. Okay, so now we should be able to do, is this right? Okay, so now we should be able to say, there isn't LSP for that. That would be pretty cool. I have not looked into that at all. But so now we can do my times of A times AB. Well, let me show you what times AB. So times AB, all it returns is itself, because there's no rule in its list of defined rules that match that it knows how to simplify that. So that is, in essence, the simplest way to represent that expression. Now, if we did my times that of 0, then we get 0. So we don't even have to really modify our expression structure. Let's see. That'd be so sweet if we could get LSP integration. That'd be so random. Nice. That would be so random for me to hook this into. I mean, because it's like this language is barely a language, and then we already have LSP support for it. There is a simple and composable framework for implementing asynchronous services in Rust. That would be crazy, dude. That'd be so cool to hook into language server. Oh man, you got me thinking, bro. You got me thinking. Not for right now, but we could do it. You want to open an issue or something? I'll put that on the docket. But first, we got to get the pattern matcher working. Because if we can't do cellular automata and sequence matching, then the whole thing is a bust. So we got to get our core language features first. But then I'm super down for it. And by the way, when I do times a b in here, it self-evaluates too. So it just so wait, let me call this full form so you get the full, and it returns itself. So basically, we see that there's no simpler way to do this because a and b aren't undefined, so they're just symbols. Yeah, no, I totally agree. I mean, I don't know if you noticed somewhat, oh, but I do have the little blue colors to help me. But yeah, I mean, that's why S expressions are clearly not as good as having these M expression for, was it called M expression? Yeah, M expression. Yeah. I was thinking of writing another M expression parser with no infix. So nothing, no infix support, but just a basic M expression parser, just so that I could start to make my life a little easier. If you want to do that with Peg, I would be super. That'd be like freaking cool, because then we could not have this horrendous nightmare of parentheses and parentheses. I will say you get better with it, and I think I did add that you can do like my times enter a b like that. Okay, I guess not. Wait, let me add a space. A space. Oh, wait, no, I think I know what it is. Okay, so I made it a like slightly more, but with multi-line editing. But do I know about tracing? What do you mean? Oh, that's cool. I can zoom in on that. That's like the highlight. That's like the essence of this stupid. My parser is so ridiculous. Lisp always gets hated on for its parentheses usage, though. Oh man, that's funny. But one advantage of this, you never ever. I mean, M expressions don't really have this either, but you do not have to worry about precedence. And I always hated when I was in like high school, and I would have to like put something in my calculator, and I would always add way more parentheses than everyone else, just because I didn't want to remember PEMDAS. Yeah, I think that Peg has some like tracer built into it actually. So it does have tracing. I mean, at least we get this minimal thing where it tells me that I expected some sort of token. Um, yeah, it's a priority thing. Like, I only have so much time, and my goal is first start getting like cellular automata and cool computational systems, and then once I'm like in a mode to like really use my own language, then I can like start to add more stuff. But there's like too much to do, and it's kind of overwhelming to like get lost in the weeds when I just want to get my pattern matcher to be at least like right now list operations basically don't work. So how are we going to do anything with like cellular automata if we can't just append to a list and stuff like that? Actually, let's see. Can we define join? Set my join takes a list. Yeah, I'm trying to think. Without sequence support, it's kind of because what you would do here once I integrate the new. Let me zoom in. Am I blocking it? I don't know. I don't think so. Once I integrate the new pattern matcher, I would do list pattern at x is blank null sequence list, or actually what I would do is I would define pattern lists where I give it a blank null sequence. Or actually, let's say it's a blank sequence of with head list. Then all I would do is I would make list of lists. And so then, oh wait, but is that true? We would probably want to do like replace repeated list rule list goes to sequence. And I think that then that would join lists together. There's like lots of basic stuff that is just going to be really tough to do. And without sequence support, basically nothing is possible. Yeah, I'm going to zoom back out. Okay, so where were we? Right, so here we were thinking about the case where if pi blank dot len 2, we need to make sure that if b head not equal to head of seq e, then we need to break. We need to break, I think. But and we need to comment this out. So unless we need to consider borrowing here. Well, we don't mutate it, so that's fine. We can just borrow this like this. Oops, where did I go? We gotta clone it. What's wrong here? Clone it again. Wait, hold on. Yeah, that's fine. Okay, so my problem is I don't know if that I think we need to return false there, right? I think we just want to Maybe break is okay. Let's try it on our test case here. So I want to cut this out. I'll put this at the end. I think I'm still kind of zoomed in. No, definitely not. Alright, so I'm going to undo all of these cases for right now. I'm going to run this. Where's this stupid hello world? Oh. Oh, wait. That's not good. So it did match, but then it didn't insert what we needed it to insert. I don't know, I'm getting this suspicion that this could run forever somehow. See, does it print here? It should insert, right? Yeah, so it does insert into it. Oh, but it returns false. Right, so wait. This is the false case? Yeah, so hold on. Since it returns false, it doesn't matter what the map is. We want to add a BD here. Cool. Nice. So that actually worked pretty good. All right, so let's add that to blank null sequence 2. A lot of code. And then here, okay, the loop downs are still good. And then we want to do that same thing here. You have to be careful about. So here, okay, that looks good. A moment of truth. Nice. We need to add a bunch of test cases. Looks very C++ to you? The language or the implementation? The implementation I could definitely see. I really have never used C++, to be honest. Like for a real thing, I've never used C++. But I actually kind of want to implement this Mathematica clone. Oh yeah. I don't know. I'm not good enough at Rust to like do it the right way. So this is all just me like bumbling around like a fool. Okay, so let's do this one. We remove the pattern. Damn, that stinks. I don't see why that failed though. At one, you replace that with those two lists with a sequence of those. Oh wait, it doesn't look like it's putting it in a sequence though. Shouldn't it? Do we store the? I guess we don't store the sequence. So what we want to do is we want to do this regardless, and then we want to say assert equal rebuild x. What? Oh. Oh, I'm tripping. Okay, so consider deref. Oh, panic and deref is scary AF. Yeah, bro. Yeah, it is. It is. You better be careful, because it is scary. We live on the edge here. Yeah, dude. The panic and deref is wild. I actually don't want it, but like the problem is it makes the code annoying because then I just have to constantly match. And maybe on my like 5th go around of writing this pattern matcher, I'll finally do away with the deref. But it's just so handy. It's just so handy. Actually, instead of panicking, I should just print. I can replace match if else with match. Is that true? All right, hold on. You give me overload. What I want to do is I want to debug this thing really quick because this. Oh, you can do that? Yeah, I forgot about that. And will that tell it that it's. Yeah. Okay. I should do that. Yeah, that's nice because I do want that actually. Oh yeah, wait, hold on. You should print this above here. Oh, I don't really care. Let's just disable this. Sim is just a handy thing to convert a string to a symbol. So it just takes a pointer to a string and calls s.toString. Maybe you can directly match. So we can generate the jump table. Okay. Yeah, you mean for performance, right? For performance, I mean, because I allocate a symbol every time I do that comparison there. Oh, but I do need to call this. Okay, so this shouldn't panic, so I should be able to do let this, yeah, comma, yeah, and then we can comment this out. Okay, now I should be able to see. should be able to see what that expected. Wait. Damn, dude, I wish we could just hop on a live share or Discord and you could just help me do this. No, I want to focus for right now, but let's see. All right, hold on. Maybe, yeah. All right, wait, let me just like do this for like 20 more minutes. Maybe you could hack around on it locally. I just have to make sure that I get this pattern matcher to work because otherwise I feel like I'm gonna lose it. I feel like I'm close. Okay, here's where the comparison failed. So for some reason, yes, we had sequence of 2 lists, so that's perfect. That's what we wanted. But then it didn't rebuild. Why didn't it rebuild? The POS map. Oh wait, it's empty. That's not good. But it does. Okay. What could be going wrong here? Yeah, so this case, so okay, let's go back up. So where we printed this, we print this. We say at position 1 in the pattern, which is blank seek A, we get this list sequence of AB and another call of AC. Then we insert that. No. All right, let's see. Why did that not rebuild it as we expected? Oh wait, this isn't blank null sequence. Did we just not do it for? What happened? So wait, we need to move this. But that is exactly the right thing. So we should have returned true here. What the heck is going on? Yeah, but add me on Discord though. You should add me on. I think it's linked in my thing. We should definitely do that because you seem interested and I love the idea that someone's excited about this because I think this is super cool. Oh sweet, that's tight. You can add me as a friend too if you want. I don't check Discord a ton, but I think maybe as if people start joining, I'll keep it open on my computer. Dude, you're the best, man. You're the homie for real. Okay. I copy that over too. Move that garbage. Man, this code is getting so nasty. It's crazy. So much copied stuff. So why is it that in here, because this definitely is true. We can see that in positional, the new expression is exactly equal to the original expression. So this should return true, so then this should return true. But for some reason, we're getting an empty. Am I being crazy right now? Let me look at my original code in match 2. What do we do at the end? After we're done iterating, I thought we have that. Oh yeah, right here. Final comparison. Oh wait, we actually prefer this. I know print debugging is pretty cringe, but I am at a loss because I don't really know. Oh, well, that is certainly interesting. That is random as hell. Are we just indexing wrong? Are we rebuilding wrong? That could be. That totally could be. Can we do this? Okay. Okay, yeah, so the first thing we do is we say, since a blank sequence, the minimum length has to be 1. So we take the first AB list. And now we call match again with the rebuilt expression, and we splice in this sequence into the expression call match again. Then we say, so why is A there? That makes no sense at all. What? What am I doing? That's so not right. Yeah, I don't see anything mangling it like up in the named case. But, and then the old is just AB. I feel like we're replacing, I feel like the position is being calculated wrong somewhere. Yeah, because it's like one level too deep. I feel like we're pushing somewhere where we shouldn't be. But I feel like we use position, well, we don't use position in the named case, so that could be. So we push I. Which should be right, isn't it? Because this, where did C go? So yeah, okay, so let's look at, this is what our test case is. Our test case is we have a list with a symbol, and then we have AB, AC, and BD. And what we're trying to do, and the way that Mathematica works, is that if you give blank sequence or blank null sequence an optional argument called H or A or whatever you call it, then you need to make sure that that argument matches to all the lists that you're matching. So the head of this and all subsequent things needs to match the argument in the blank. And so what we're trying to say is that in this test case, F matches to F, and blank sequence of A cannot, what we're testing is that cannot steal this guy because, oh, I wish I could zoom in with like a nicer zoom in. What we'd like to say is that, and I think I have this case, that we test that this is false, that this blank sequence cannot eat up this BD list because we put a restriction that the only things that it can match are things with head A. So that's a description of the problem. And for some reason, even though that these test cases work correctly and we can see the maps all work out, for some reason, we're seeing something interesting when we're doing positional. And a broad description of what's happening. By the way, what's your name? I'd like to say your name. I can just say your username. Olala. A broad description of what the algorithm is doing. Ollie. What's actually happening is we keep track of where we are. As we recurse the expression tree, we keep track of where we are with respect to the pattern. And we call the pattern as the second argument to the match function. And we keep track of that position so that if we have an unnamed pattern, we can replace it given this vec of u size. So we have this pos, which is a vec of u size. And this says, where are we in the pattern expert? And so what we're seeing here is we have this is our position. I print out this vec of u size here. We have a 1, and we're saying the position 1 in our pattern, which should be this, name, so in named patterns where you have this explicit pattern symbol blank object, name matters because if you have in Mathematica, if you have let's see, f of a, b, a, c, and you try to match that with f of, I'm not sure how you can match to lists, two lists to a nested list. It'd be easier if you wrote out the expression. The two lists, how you can match two lists to a nested list. Yeah, well, what happens is you peek into the nested list and you say, is it a pattern object? And if it's a pattern object, then it can match multiple ones. And specifically for these sequence ones, you can take multiple. So this position 1 should refer to this. That seems all right. I don't know. It's for some reason we're just messing up. And here it's just because it returns false, so something goes wrong in the final comparison. Oh, hold on. What's going on here? Oh no, here's the one. Sequence ABAC. I should just use the debugger. I don't know what the heck I'm doing. Yeah, it's kind of I would say let's see. Let's just do this. My other streams have good let's see, do we have an example of a minimal? So in here, I think that this is the minimal example. Yeah, okay, so this one, I'm going to push this to GitHub just so that you can read some of the other examples of pattern matchers. This is the simplest pattern matcher where blank is a symbol, not a list, and cannot have a head. Then we go further, and so in our case, our wildcard is no longer just a symbol blank. Now we have blank as a 0 argument function. This also supports named blanks, i.e. pattern x blank. And let's see, do we have head support here? Yes. With an optional first argument to blank for head matching. Okay, so let's do this. gh repo create cas5. These are all arbitrary names. Okay, let's see. Added some comments. Let's make sure that tests pass to CR release. Okay, so that should be okay. And then I'll push it. Okay, so then let's go to GitHub cas3.rs. Okay, so this one should have a minimal pattern matcher where we don't have sequences. So this is the non-sequence case. Cool, just in case. So this is the minimal one. And then why don't I put up matcher 2? I'll put up matcher 2 as well. This is an old version of pattern matching that has some sequence support, but is loaded and buggy. Does not support. So let me add the comment actually in here. This is so messy. I'm not going to clean this up because we're already on to the next thing. Does not support I'll put it all caps. Does not support unnamed patterns. No position tracking. Okay. And we'll just do this again. I don't care about spamming GitHub. I'll just call this matcher 2. I don't know. These names are nonsense, but I don't think I really care. Okay, so we have that one. So that's an example of a big bloated thing. And then did I push cas3? Oh, let me push this one because this is the real one. Oops, did I mess something up? Okay, I'm gonna call this cas3. Let's call it init. Alright, so now everything should be up, so at least I don't have to worry about, because I was trying to view this on my phone anyways, and I couldn't. But no, back to what we were on. I'm pretty sure the problem is related, is just that we are comparing the wrong levels of positions. So for some reason we think we're deeper than we are. So we're trying to that's how we get this AAB thing. Where is that? AAB. Alright, so I wanted to run this again where I print out the original. See what's going on. Oops, good. Right, we're in here. We're replacing. Right, it needs to be relative. It needs to be relative when we rebuild. So we need to chop off. Yeah, that's right. Okay, so I think the problem. I don't know if it's in there or in there. I think the issue is a depth mismatch. Basically, but actually, why is Pat AB? That doesn't seem right at all. Or is it that we're rebuilding twice? Damn, I'm so close. Testing case 2. Okay, first we do the obvious thing. Okay, in positional. Where's that? In positional. And we've already replaced. Is this right that you apply all the rules you've accumulated, or is it that you've... What happens if I do this? Do something crazy. I feel like that's just wrong. Oh. Wait, but I feel like that's wrong for all of the other cases. There's no way that's right. But in some sense, if you get to there, maybe you just don't need to rebuild at the end. It seems like we figured it out. So let's actually look though. Sequence ABAC, that's pretty nice. Okay, I'm a little sus that this is right, but let's make sure that we actually that we run our tests. Yeah, that's what I thought. That's what I thought. No way that's right. Yeah, because we're just not doing the replacement. Wait, what? Wait, why did this return false? Yeah, no, you're definitely supposed to, And I'm pretty sure it's because all of my test cases are flat, and this one's not flat. So what was Pat here? Make sure we do this. Okay, let's disable all of our guys again. Except for the last one. Yeah, it's replacing it too deep. Named. Okay, here we go. Alright, Pat is not what I expect it to be. Right, so we have the right thing here, but we have the wrong. We have the wrong pattern. I'll be right back. Alright, it's time to use the debugger. It's time to bring in a hammer. Alright, so now we wanna break at, wow, this thing turned into a big ass function. It's kind of annoying. Alright, let's try it. Why doesn't it, I don't like that it doesn't, I really don't like that. I have a debug color, right? I should be able to say X. This thing's stinky. Right, that's correct. Now we're matching the head. Now we're saying, and it doesn't. Okay, So like that. We're matching F with F, so we're good. Nope. Passes 1. We have a list because it's blank A. It's a blank seek A. We're looking at so Pat, I wish it would just tell me what it is. It's super annoying. Okay, so we're going to jump over this. Okay, then we're going to go in here. Dude, just print it out for me. So why is else length 2 already? Damn, I wish it would print it out. Stupid. Makes it like not that useful. Okay, cool. So now we want to match. Yep, that's good. Okay, so continue. Okay, so we've popped back out, right? Yep. What is it? Is it LLDB? It's the LLDB one, right? Seems pretty mid, honestly. Um. Oh, that call stack thing is kind of nice. Oh, and it stores where we were at. That's pretty cool. I just wish it would print it better. Hmm. Damn, I'm so close. What is Pat at this point? Oh, what? Hmm. That's it. Why don't we ever see a 2-1 here? Or 2? The pattern is BD? Why is the pattern BD? Okay, so we're in here. We get our list. We don't need to think about any of this. Okay, so now we're matching AB and AB. So that's where that's at. Wait, but we're not in there, we're in here. Maybe that's like the problem. Let's try it. I just think this is totally wrong. Could it be? There's no freaking way. No, what? I think we did it. I don't really believe it yet. It's too good to be true. Did we really do it? That's crazy. There's no way. If that's true, I just don't understand the algorithm. Why do we need to recurse? Do we do it up here? Oh, I guess we do. Interesting. Man, I miss Ollie. Ollie would be proud that we got it working. Sweet. So let's make sure that what? I think we might have fucking done it. All right, so now we have a rebuild in here. All right, let's copy it in. Let's see what happens. This would be nuts if we could just get this to work. Damn. Okay, so what's going on? Okay, so that's okay. So let's start at the top here. Give it a pointer. Oh, I think we could actually just do this. Sometimes that's useful. I don't know. I don't want to put a bunch of trash in here. Seems like a lot of trash. Let's go back down. Yeah, this works except shit is almost too good to be true. This is missing. So what we want here is E P. Now, is this true or should this be a blank? Oh, we just switched the order. I got it. So we make this blank. Then we move it to the bottom. You don't have a parse function? It's random. Moment of freaking truth. No way. No way. I'm gonna cry, dude. We did it. We integrated the new pattern matcher. I don't believe it. I don't believe it. Yeah, I think that's right. What? Oh yeah, that's right. One of them. Oh, I need to give it a pointer here. Oh man. Yes. Do I have length? We don't have length. And now we need to make all the rule stuff use the new pattern matcher. So all the replace needs to do pattern. Okay. We're actually gonna so we're gonna yeah. I mean, this is just so error prone because when you make changes like this, you have no idea if you're using match Q. So it can be really messy. But in both of these, we can change this to oh hey, what's up, dude? I didn't know you were still here. Oh, you left. Dude, we did it. We're almost done. I'm integrating it back into cas3. So I copied it in, and I think everything's working. I put new tests in. We just need to make this and this sick. That's so cool having you along for the way, dude. This is a really big achievement for me, honestly. Like, this is really, so now when you replace, this is a good question. That's sick, dude. Oh, you're the fucking man. The position should be new, right? If we're calling match, then we need to do maybe we should have a helper that does this thing. So we'll just call it isMatch2, I guess. Anyways, it takes an x of type pointer to expr and a pat of type pointer to expr. And that's all, and it returns a bool. And it basically just does my match of x pat vec hash map did not render that. New okay, what's wrong? I need to give it a pointer. Expected pointer. Pointer mute. And pointer mute. What's wrong with Pat? I need to clone it. I don't know. Some of the things are really rough around the edges, but interestingly, the other one in replace takes the bindings. I need to remember everything that I did here. Oh no, oh no. Okay, cool. That's what I thought. So we can just get rid of this. And this we can remove. Oh, huh. No. We need the maps. We need the maps. We need the named map. We don't need the position map because that's just used to verify that we found a matching, but okay, so I'll just call my match. We'll say vec of blank and give it a pointer. Then we need the pos map, which is going to be a pointer to a mute hash map new. And then this one is the bindings that we keep around with us. This we got to clone for some reason. No need to do that. I can use the slice ref. Yeah, this is something I wish Rust helped me a little bit more with. Is like, yeah, okay, in like 5 minutes, I'd love to. That'd be sick to have us. Yeah, dude, absolutely. Give me. Let me just see if it works, and I want to test a couple cases, but then absolutely after that. Okay, so bindings to rules. What does this take? This takes a string. We need to change this. Okay, we need to change that really quickly. Man, I've never built a project like this, so I'm prone to duplicating code really messily. But we need to change this to, we're going to call this pat bindings to rules. And here this takes an expert, and we just need to get the name out of it. So this is pat. And then I need to do this or something. Okay, so now this should be a sim. We should be able to just put the name in there. Clone it. I don't know. Okay, so it says borrow there. Then it says, what if I just do this? So it's saying put ref here? Okay. Oh, wait. That's what I want to do. Remember pattern X blank. Okay. So we grab that guy. Does this get called anywhere besides? Okay, it just gets called one place. So we need to make this pat bindings to rules. Do that. In this hash map, because we want to actually replace this call. So we want to put this here. Damn, keeping a code base clean is like hard. Okay, so now let's try to run these tests again. I feel like I missed something. Fuck, man. I actually like this without the loop where I do this. Okay, well, let me play around with it, try to isolate this issue. Well, let's look at this print where. Damn, what's going on? So our combinator one, for some reason, is failing. One, two, three. Oh God. I knew it was. Alright, let's hop on Discord. I'm gonna revert this. We should copy this because we're gonna. Okay. Oh shit. Wait, oh, it's because, of our built-ins. Or I can call this new match, and then this is supposed to be match Q. Okay, let's see. Damn, I thought we had it. All right, we're gonna have to go back. So I'll just say, what are all the changes in here? It's a nonsense. All right, partially got the new pattern metric. Still need to debug this. Do I even have Discord? Maybe I don't. Oh wait, hold on. Let me do this really quickly. All right, unmute.
Okay.
What's up, man? Huh?
It's a
Yeah, it's a mess. It totally is a mess. It really is. All right. Yeah, that's me. Sort of, yeah.
yeah, so
Mm-hmm. Yeah. Right.
in the meantime,
Yeah.
like the vector
So what about a pointer to a vec though? Oh, I see. That's what the ampersand is. Oh, I see. Okay. Right.
is right
Okay, so you're saying that all the places where I have a vec, when I can borrow the data, I have to think about
yeah.
that.
Or you can just
Um, yeah. Do I have live share in here? Let's go live share. Yeah, it makes it a lot easier. As long as you promise not to RMRF my machine. Yeah, yeah, no. It defaults to read only, but all right. Let me oh, hold on. Let me just authenticate really quickly. Okay, should be good now. Okay. All right, put it in. Say that again. Oh yeah, this seems like an interesting thing because I'm coming from Julia. Like I used to write a lot of Julia code, and they have no there's no notion of putting like impl. Like impl isn't really a thing. So that's why I have all of these functions not impl. Um, I looked it up. Not really. Still not really. Almost all dynamic languages, Python and stuff like that. Yeah, yeah. So, but is there any issue with this, or the fact that it just kind of sort of clutters the namespace?
Yeah.
Oh, yeah, right. And you can tab complete it easier, huh?
Yeah. And also,
Hmm. Oh, yeah,
anytime you extend,
yeah, yeah. That makes sense. That seems like pretty in the weeds for how performant I expect it to be. But no, that's a good point. I didn't think about that at all. But could the compiler not figure that out based on the type signature either? Hmm. Right. Yeah, you're right. Different line. Yeah. Uh, let me do this really quick. Does this work? Cool. I think I did. I put it in Discord. Oh yeah, sorry, I could have DM'd you. My bad. Uh, nice. Okay, yeah, sure. History is uh every time you put a command into the REPL, it will save a text file so that you have your history of what commands you've run, so you can reverse search. Yeah, yeah. No, I think just cargo new started with slash target, so I don't, never mind. Cool. Where are you? Let me click follow. Okay, yeah. Okay, sure. Oh, sure, yeah. It's all right for right now, I think.
yeah.
Yeah, sure. Yeah, yeah.
Yeah. So, 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 yeah. So
Yeah. Yeah, sure. Go ahead. Here, let me branch so that we have. Let me branch really quick. Stream changes. All right, cool. All right, go ahead. Yeah. Oh yeah, you in car. Let me follow you. Cool. Yeah.
Yeah.
Cool. Yeah. Okay. Yeah. I saw it somewhere and I just put it in. Yeah. I really wish that the formatter would do that for me. I always expect it to make it like optimal where it sorts out the tree, but it never. And then that duplicate imports for some reason it doesn't remove them. It just errors. It's just a gripe of mine. Like if I have two standard collection hash maps, this one errors, but if I try to format, it doesn't remove this one. I just find that really odd. Oh, okay, cool. Yeah, right, right. Yeah, yeah, yeah. Okay. Let me look up these crates really quick, just see what they do. Okay, this one seems okay. It's from Tokyo. All right, I trust that. And then tracing subscriber. Okay, cool. Okay, cool. I just added them. Oh yeah, we can get to that later, but that for right now we're good. But yeah, I or is there something that would? Yeah, no. Go. I mean, I can add clap. I just remember it taking a while to compile. I was, but yeah, yeah, yeah. I guess I could add clap. All right, I'll clap. Let's see what happens. All right, I just added it. Oh wait, I can do that from the. Okay, yeah, you can do that. I can add it from the command line though too. Nice. Let's see. Yeah, ENV filter. Yeah, I found it. Cool. Whoa. Okay. Oh yeah. Yeah, I've had some bugs with I can I can put it in. Yeah, it's kind of annoying. And then let's see. Hold on. Gonna need to fix these. Um, oh, I see. Okay. Okay. Cas3, yeah. Yeah. Okay, cool. Cool. Uh, oh yeah. Yeah. Oh yeah. Hmm. Yeah. The only thing that's cool about it is that it's homoiconic, so I can copy and paste it, and it's a valid expression. Right. Like whatever. Oh, I see. Okay. Yeah. Okay, that makes sense. Yeah. Because at one point we had like display would give me the S expression, so FAB, but then this one would give me expr or debug would give me expr list, sim expr. Oh, do you see? I'm okay. Yeah, sim f and it would do vec. So it would print out this nice thing. But yeah, no. If I mean, I don't know if that's standard, but it was nice that like this was the display, and then this was the debug. Because debug is just when you print out like this, right? Yeah. Mm. So what else would I want to log there? What else would I want to put in there? Yeah. Mm. Yeah. Okay. Yeah. What? Look at what? I can. Yeah, I'm following you. You're looking at the parse function, but what is wrong with this? Yeah. I gotta be honest. I'm a little bit partial to liking these non-impl forms. I don't know. Maybe it's because I'm coming from dynamic languages, but I like the well. Can I do both? Can I do impl expr? Oh wait, hold on. Let me stop following you really quick. Okay. Can I do impl expr parse? Um. Or wait. How would I do this? Because you wouldn't want to do expr dot parse, right? Because expr is not a string. Oh, okay, yeah. All right, so S type pointer to stir and goes to expert. And we throw otherwise, and then we basically just call this. Right. Yeah. 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 True. But I wouldn't delete this one out of convenience. So maybe I would just mirror them and keep two implementations. Because I like being able to just write parse in a string. Huh? Yeah. Well, yeah, I guess it's just that I prefer this one. I just like writing things like this, where I just call parse of string. But yeah, no, I know. All right, well, let's see how it goes with. All right, so let me just say to remove because I have a whole bunch of tests that rely on parse, but we'll keep this one and see. I'll see how it. I'll use it for a bit and see how it goes. It's just I have to type a bit more, but I see that it for what? Where does it error? Huh. Hmm. Yeah. Well, in this case, I feel like it's clear, but for something more complicated, I get it. Yeah. Yeah. No, no, yeah. You're doing things the correct way. That's for sure. Yeah, that's a lot of detail, but I guess it's what's required to make a real project. Um, yeah. Mm, yeah. Huh. Yeah. Hmm. Does that sort of steal the error that gets thrown? Because on unwrap it gives me the parse error. Oh, okay, cool. Yeah, that's nice. Yeah, because it's nice that the unwrap tells me where the parse went wrong. Cool. Yeah. 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 There's a lot of stuff in here where I just yeah, yeah, yeah. I mean, to get it to work, I just well, hold on. Where? Let me follow. Oh, these. Yeah. Uh, but I like them. Yeah. No, I know that. The I guess the reason why is this project is a little bit of a in a unique case because it's not meant to be used as a library, right? It's more of an application, so it's like almost under the assumption that nobody should ever touch this code in the first place. Um, but yeah, I mean, there's no difference. Huh? Yeah, yeah. All right, so we can put them in info. Yeah, I was trying to figure out what the thing is to make it slices, but I didn't know. Oh, nice. Yeah, I like that. That's List E is just it just instead of taking strings, it takes expers. For expressions. Yeah. Oh wow, hey yo, someone raided me. This is the first time this has happened, dude. This is sick. What's going on, guys? We're this guy Ollie just joined today for the first time, and he's helping me make my Rust code less awful. So we're seeing what's going on. Right now, I panic all over the place, and he's telling me how to do things correctly. All right, so yeah, yeah. Yeah, that's the case where you have just like a blank parentheses. You're not allowed to do that in Mathematica. Yeah, I haven't. I forget exactly. One thing that's interesting that Mathematica does is that when some computations fail, they'll actually let me go to Mathematica really quick. Like they'll actually return a symbol. What's a case where you get failed? Uh, but it just returns a symbol with called dollar failed. Yeah, like open read, non-existing. So this one's interesting. It does throw a message, but it actually just returns a symbol. So that's sort of a convention that I started to copy with that get fucked symbol return. Yeah, so this is still a valid expression, exactly. Because then I don't crash the program or anything like that. I just throw a little error. Um, Rust needs to be ugly. That's what that's the chat is saying. I actually kind of agree, but I have a I feel like I've accumulated some bad habits though, as you've seen. Oh, another. You're saying a new. You're saying a new enum branch. Yeah, and then you call error. Yeah, yeah, that's kind of nice. Wait, but let's revert these. I feel like this is fine for now. Yeah, I feel like we don't need the error call. All right, cool. Yeah. Yeah, pretty much all of the like little helpers for oh yeah, apparently they can't hear you. Let me try to change that. Okay. Wait, say something now.
Hey,
Oh,
hello.
okay, I think they should be able.
You know what? I'm not sure if it's a good thing because Clippy actually replaces that. I mean, it emits a warning, but there is the macro matches,
Oh yeah,
and
I've seen that. I think might use that in one of the other projects I was messing around with.
yeah, and you could do it like that, list like that.
Yeah.
Oops, mistake.
Oh, that's
And
actually
that
pretty
would be
nice. I'm kind of down with that. That's cool. Just leave that as a comment for now. Yeah.
yeah.
Do you have a limiter on this output? Why? Do I need? What is that? Should I turn it down?
Limiter.
I'm just trying to make sure that their audio
Oh,
is.
yeah.
We hear them, but low. Oh yeah, let me just turn me down. Okay. What about now? I think it should be. Ollie, say something again.
Hey.
Okay, that's all right. I
uh,
think we're about equal now. That should be okay.
I guess. Um, Red table entry. Instead of calling those, like creating those variables directly, you could use your helper function you defined on top here.
Instead of. Oh yeah. Wait, don't I?
Yeah, so then it's
Oh yeah.
because no, you don't, because instead you can use what's it called, like expression from string, and then you can like list. You could use this instead of
Uh.
list.
Well. Yeah. It would be like that. But yeah. Um.
Yeah, I'm not idea what to
But
think
actually,
about.
but
Yeah,
before, but let me stop that right now. We're actually gonna need to change how this works, anyways, because
yeah,
the list of the way that Mathematica works is it actually has it has a list of rules that are stored for a given symbol. So down values are basically they store some symbol and map to a list of rules. So for f of x equals x, for example,
yeah. I
but you can
understand.
also
Mm-hmm.
define f of blank equals the string high. And so there's actually an
Yeah.
insertion order defined where they look at what pattern you're giving it and define some sort of how specific it is. So f of x is actually more specific than blank. And then going even further, if it's like an atom, f of 1 equals hello. So this gets inserted
Mm-hmm.
before these. So this is sort of just a hack to basically enforce that the user has to supply like rules that are defined in the order of most specific to most general. So just later on, I'm gonna have to do something to make this more. Instead of just appending to this list, we're gonna have to do something smarter. So that's just some context of why it's not really fleshed out. It's just sort of not well thought out.
Oh, so sim creates another expression, and then this one it creates from expression.
Yeah,
So
so you could
essentially,
just
it's
call list here. So you could just do this, and this would be the same thing. Um,
yeah, I got it. So if you were
oh
to
yeah.
unwrap it, that would be like expression from expressions, and that would be like that, right?
From
Expression
expression.
from
Yeah,
expressions, and
exactly.
it's pointing from. Yeah, okay, got it. Yeah. I mean, definitely the way with some kind of constructor would be nicer, I guess. Here,
Hold on, let me. Oh wait, for some
because
reason.
essentially you. Oh yeah. I mean, we can just control Z like
Yeah, for some
at the
reason I
beginning.
feel like the history got like messed up and I was undoing stuff I shouldn't have. So, anyways,
Oh, I remember this thing. I'm not sure
yeah, I think that's
what was it. Oh, okay,
probably.
it was listing. Okay, yeah,
Oh yeah, okay, cool.
good.
Yeah, Listy. I was like when I made that I was like, wow, this name is awful.
Listy, yeah. Hmm.
And I
What's
feel like
happening here?
I don't actually know if I use this or if I manually do it. I probably call it a few times. Yeah, I call it once. Basically, given an
Oh,
expression.
because yeah, I get it. This whole thing could be written as math u to like that. That's it.
And what happens? Oh, and it just propagates the option. Okay.
Yeah, yeah.
That's pretty nice.
Mm, pretty cool.
I feel like to get good at Rust, you have to know these things. Like otherwise, you end up writing a lot of code that people have already done.
Yeah, definitely. This one can also be an import, right? But I'm not sure about that because not sure what it does.
The stack.
No, internal function supply. But yeah,
Oh
it's good
yeah.
to know. I mean, I need to read a bit.
Is that how you would do this Rust idiomatically? I'm trying to think. Um, so the
I
general,
just no idea what happens here.
yeah. So
So
the general, so
if it's possible, yeah.
go down to the function evaluate because there's basically two things
Function
going
evaluate.
on in they do fn evaluate. You'll find it. Okay, here. So there's basically, I mean, Mathematica works very simply. You start up the program and then you give it an expression and it returns the result of that expression, which is another expression. So you have this expert to expert signature here, and then there's just some other context that you keep around. Yeah.
Yeah.
So you can see in the
You get
main.
the point.
Yeah, I get it. Yeah. But I still don't like. I know that it's Rust. Like Rust people say to do this as impulse, but yeah, I have trouble figuring out why you need to. Besides this thing about the cache lines will be close together.
It will be in cache line if you combine it constructor, but you don't need to think about that. That's just a minor performance detail. That's not the reason to do that. The reason is that you get your methods on your structure.
Right. Yeah. Okay. The tab. I have to use that for a while. Maybe I'll make a cas7 and I'll try to do it all with impulse and see how clean it feels to do it. Because if it is easier to write them, then I can see why people do it. But yeah. Okay. So yeah, that makes sense to me.
Yeah, we can definitely do something with those clones because there's a lot of them, and obviously something to do with those literals, like those sim things. Because again, I'm not sure if they're part of spec and if users are allowed to extend them.
Yeah. Sorry. Say
I'm
that
talking
again.
about those
Oh,
like
this.
these things, right? I guess that's one of errors, right?
Yeah.
Oh, for instance, this thing, right? Like, oops, misclicked. Like this thing here. Like,
Yeah. So
why does it
that.
say list inside?
So okay. So the way that Mathematica works is there's a head called list, and it's an
No,
empty.
I understand.
Oh yeah. Yeah. Okay.
I understand. I'm not about like details of a spec, but why do you have list here? Like, why is this string literal? Like, does it happen one time? Like, you have part here, right? I mean, could they be potentially like if they are part of the spec, like those words, if they're like keywords or whatever,
Yeah.
why wouldn't they be like a method?
Yeah.
Like,
No. They
why don't you
absolutely.
like
You're
a
right.
if?
They absolutely should. It was more so that I was just coding, and I didn't think to like
Yeah, right.
refactor it out. But you're absolutely right that all of these things where I was thinking though the design for these internal functions, like you may want to have some sort of hook where you like specify, all right, here are all the built-in functions, here's how many arguments they can take, stuff like that, so that as you register them, you get something more. Because I would keep running into this thing where I expect some number of arguments to some of these functions, like times. here times only takes 2 arguments, but times in Mathematica can take a variadic number of arguments. So I guess the point is maybe by having some way to register functions, you can say, okay, this can take this many arguments and whatnot. So anyways, the whole design of this internal function apply, I don't really like. But yeah.
Makes sense. I'm sorry. Why do you convert I size to I size and then you unwrap it?
It was probably GitHub Copilot. It's probably a GPT or GitHub
it
Copilot.
Says it's integer. Yeah, wait. It's kind of weird because when I hover my mouse, it says, "Oh, it should be fine." What should it be? To I size.
Oh, it's not even showing up a. Well, oh, you know why? Because that integer is a it's from rug, so it's yeah. So it's a big int.
Yeah, so I think you could actually avoid that unwrap if you wrap the integer, or you could emit the actual error here. Because I'm not sure what spec says about that. I used to post swallow the error if it never happened.
Yeah.
Or we can just admit that it's out of bounds.
Yeah.
Yeah.
Because
again, wait, what happens here? What is ls? Ls.
Those are the list elements usually. Let's see, they're up here. So,
what's happening here?
Yeah. So
why do you match lists 3 times? Wait.
I don't actually remember. I think it was so that I can index a list with another list, or index a list with an integer or an index. So there's
you need to look into that because it definitely can be written less messy, I guess.
Yeah.
Because you have you match list here, you match list here, you match not list. Can you return a list? Yeah.
I can hear your disappointment. Yeah. That's hilarious.
No, it's fine. I mean, totally fine. Yeah. Oh, yeah, we win here. Wait, what is that?
That's probably the pattern match.
Oh god,
that's the new pattern matcher.
Wait, is it a single function? Wait.
Yeah, it's just one function.
I keep scrolling.
Yeah, no, I know.
Okay. I mean, it's totally reasonable. It's right under 400 lines of code. Yeah. Is match is perfect candidate for including it into impl block.
Yeah.
Yeah. And you could also have some other structure, obviously, that would maintain all your, stack, like parsing stack.
Like the evaluation context?
Stack, whatever.
Yeah.
Yeah. Because here you pass your hash map, everywhere.
Yeah.
It's definitely not another way to go. And obviously, you could then implement you could add your impl block to your context and make it fancy.
What is that like?
I mean, additional, you could wrap your hash map there, right? And instead of calling directly on and passing it everywhere, I mean, again, bindings. I mean, you can see it everywhere, right?
Yeah.
You could just use it as self here. Obviously. So let me just show you.
Yeah.
You nice. Could context, whatever. It's again, I don't know what happens in here. I got the word struct, and then inside of it you would have obviously a hash map, and then here you would impl context whatever, and you would obviously add this thing here.
Yeah.
Right?
Yeah. That's nice. I like that. Yeah.
Yeah, but this thing would be self, and then instead of doing this thing where you find the function in the outer scope, and then you call your bindings, right?
Yeah, you could
Bindings,
just
whatever.
do
Yeah, instead of this, you do it a bit fancy way, right? You just you create your bindings somewhere there, like not here in your code, and you maybe do it like default, right?
yeah.
Or you could like new and pattern like your hash map if you can maybe save it somewhere, whatever, and then you do a bindings dot and you call this function here like that.
Yeah, that's clean. I like that.
Um, yeah, and you obviously don't need that. I mean, I could comment it out.
Yeah, that's good.
Again, candidate for self. Candidates for like separate functions, I guess. Guess again, I don't know the spec, so yeah.
Yeah.
This thingy
Yeah.
is yeah, I don't think you want to do that because first you clone the whole expression, so it means you clone the whole underlying. Wait, what?
Yeah, I don't know what's going on there
Wait,
actually.
wait, I have a brain like, does expression implement the? I think I have an error somewhere, like with a code highlight, because I'm not sure what happens here. Wait, why can you use this operation on expression? But expression does not. Oh wait, never mind. I understand. You have graph to
Yeah, I have
vector,
deref.
right?
Yeah.
Yeah, yeah, not good. You can get a range from the reference and then copy the range itself. Because what you end up doing here, you copy the whole vector and then you grab the range,
Yeah.
right? Um, so what you can do, you can use an iterator here, and then I think it's a range where you specify the like it collects everything from first till the last one,
Oh, is it
and
called
that's
rest
how
or
you do
something?
that.
Yeah. Yeah. Tail.
Yeah, maybe I don't remember, but yeah, something like that. It's really much better, obviously, because you don't need to copy the first element. I mean, in this case, it's only one element, obviously.
Yeah.
Uh, but then you need to pop the first element, so you reallocate the whole thing. Yeah. Yeah, so you could just copy the rest, not the whole thing, and then reallocate it again. Replace. Wait, I feel like replace is bad name, right?
It matches the name in Mathematica, but it can be something else.
Yeah, because replace in my head at least it sounds something that mutates something.
Right. Yeah. Yeah. I see what you mean.
Yeah, this thing does not mutate anything. It takes one thing, it applies these rules, and returns a new one.
Yeah, I've seen it called substitute in other places.
I guess. Okay, I got it. Yeah. What? What? Oh, okay. I see. So you pass it by reference, and then you make it mutable, so we can replace it back. Okay, I was a bit surprised, a bit surprised to see why it's mutable here.
Yeah.
Okay. I mean, you could. Why do you clone here?
I don't know. I probably just got some Rust analyzer warning.
I think you could. Wait, what? I'm not sure by bindings, but I think you could do. Yeah, like that.
Um. Yeah, that seems. Yeah, so just got rid of the clone, right? Oh, wait, hold on.
Yeah, yeah.
Yeah.
I
Okay,
think.
cool. That works.
Yeah, and you obviously don't need the sled there. Then you can
Yeah, yeah. You
just
could just. Yeah.
look at that.
Oh,
Yeah, I
wait,
think
hold
it's
on.
typo because expected what? Oh, wait.
Oh, we're in a for loop. We can't just do that.
Oh, yeah, you're right. I did not notice that. You're right. I mean, the best thing we can do, we can just put the return here.
Yeah, because what that does is it finds the first rule that matches, and then it returns.
Yeah, I got it. Norm rules, list rules. Really weird name, I guess. Norm rule. It's normalize. Okay,
Yeah.
Got it. Again, can be really nice candidate for self, because again, in replace all you would have self right here.
Yeah.
And then in norm rules you would also have self. And instead of doing this thing, like this abomination of passing rules, well, further, this rules you could easily do it like that, like norm rules. Oh, and you don't even need rules here because you have rule type of rules. So you could do like that. You could use a full name and like that. Look at that. That's beauty.
That's much better, actually. Yeah.
Findings. Again, can replace this thing with some kind of constant or method. Or yeah. Because it seems to me that those things are a bit magical, you know.
Yeah. Hold on. Okay. Yeah, no, they definitely are. I mean, there's so many. Yeah, absolutely. Yeah, I need to think about how I want to handle matching the spec of the language with like good code design, because right now it's sort of just me remembering how things work, you know.
Yeah, I understand it. I totally understand it. Again, really nice self, because that would be like self-replace rules, or maybe not replace again. That's cute.
What? Which one?
This one.
Oh yeah.
But I think we can like circumvent the map and collect. But yeah, I want to think about that. Replace repeated. Wait, what?
So replace repeated.
Replace repeated. Isn't it the same thing? Oh no, here we have a vector. Wait, but it's list. Wait.
Yeah, I remember there was something weird here. I forget exactly what.
Are those different? Yeah.
Forget exactly why I did that.
Yeah, anyway, yeah. Oh god, wait. Scary.
Huh?
Scary of it.
Well, it's kind of cool because Mathematica, if you do x equals x plus 1, it returns a terminated. It returns a valid Wolfram expression, but it's terminated evaluation of recursion limit. So they have all of these cool things like I could return, failed, sim failed there. And so the way they communicate with the user is almost always through expressions, which I think is kind of a unique way people, things are done. Here, this function, I don't actually remember if I need it or not. I remember I was trying to get the evaluator to evaluate in the right order, and I needed to, for example, what happens is if you do like set x1, the evaluation order, if I try to do set x2, this ends up going because you evaluate the atoms, you evaluate do a depth first evaluation, that you end up trying to call set 1 to 2, which is obviously wrong. So I was basically trying to make sure that these certain things that are part of the spec have what are called attributes associated with them. So I say that the attributes, this pattern, attributes of hold pattern mean don't evaluate the arguments. So I do that for set. And I don't remember if this was actually necessary or if I made a mistake or something, but that's why that exists. And so basically, I
Wait,
just
that was really weird because you define your types in and then you parse them, right? Yeah, and then you parse them here.
and evaluate it. Yeah, or I evaluate them somewhere.
Oh,
Oh no, I put them manually into the tables. Yeah, I manually put them into the table.
yeah, I see. Yeah, it's weird.
Yeah, it's weird for sure.
Okay. Oh, this one's cool. Okay. So you do not have to like provide the anonymous function here. Yeah, you can just
Yeah.
send the function directly. Yeah, yeah. Oh, look at that! You actually did sell here.
Well, I
Someone
copied
forced
that.
you.
I copied that from. I stole that from Rusty Lines.
Okay, makes sense.
Yeah.
Yeah, the first time I see that.
Yeah. There's no way I knew it. What that was about.
Oh, that's fine. Oh, that's for this file, right?
Yeah.
Path writer, nice. What? Okay. Again, you don't need to specify stack here, mutable, and then to pass in the middle reference, you can just define the evaluate on the expression. That's it.
Mm. Yeah.
Wait, what is going on here? Yeah, so would potentially look in like a more
Oh, this should
usual
probably be
code,
actually.
right?
That should probably
You
be
could
the.
do it like that. KXX.
Oh yeah. Huh. That's
Good.
weird. Yeah. No. Wait. Leave that in. That's cool. Huh.
Yeah.
But
Instead of those two lines.
that's interesting. But then couldn't you also do like x well let's x dot evaluate list context
List.
or
Why? Wait. What is evaluate? Well, wait. A second argument of evaluate is context. So if we move our expression to self, it would be expression, obviously. And then the second, we would need context. So second one would be context instead. And the
or
last
yeah.
one would be expression. Yeah. So it would be in this order, not in the
Yeah.
reverse.
I guess what is the like how do you pick which goes before the dot though? You know?
Itself is the thing you perform your action with or on.
But so why wouldn't it be the expression and not the stack?
Right, but you evaluate the expression, not the stack, right?
Yeah, so wouldn't you have like impl or here, let me put it down here
Wait, how does it work? Do you just pop next expression from the stack and you evaluate it? Then it should be an
no,
expression.
so stack is actually not used at all at the moment. That's why there's an underscore in the name. But it's supposed to just remember what heads you've hit. So if you're traversing this tree, it just remembers what the first element of each list is.
Okay. I mean, I would assume you would use stack like a context, like some kind of stack, right? You would just pop in next expression, evaluate it, and output, or maybe put it
Yeah, it's not
some
really
kind of different
that.
file.
Yeah, I see what you mean. Um,
And then you would definitely use expression as a self, because that's the I'm sorry, not expression, but context stack, because
mm,
it's stack that performs the action. If it's the exception does the job, right? Like a expression transforms into other expression, then it definitely should be on expression.
That's what I think.
Or,
I think it should be on expression. I think you would do impl expr define evaluate. I think that we kind of
I
took
mean,
that.
I mean, that's what I did here.
Yeah. Oh, right. But this would be. But I mean this x, not the empty stack.
You have to wait. You have two expressions here.
Yeah, I have two expressions. Right. The stack is
function called evaluate.
so as you give an expression to the program, it creates a new stack that's empty, and then it evaluates the expression.
Oh wait, you
with
said.
it.
I'm sorry. Wait, you're saying that there's the expression that you pass in should be empty and the one that should not be empty, like just to
Yeah.
move
So
them around?
when you start a new evaluator, like when I
Okay,
go in,
it's fine.
yeah.
Yeah, it's fine. Totally fine. Like, that's reasonable. Again, you could replace this thing with tracing, I guess. Just you could do it like a tracing error, like that,
Mm.
and then add whatever you want. It's slightly more fancy because you get the like where the error occurred. You can add the backtrace. A lot of fancy stuff.
Okay. Yeah.
You can attach your context. You could obviously run could be in something, maybe in context. Like you create the context in your main, you call your run function, and your main could be really fancy. Like can you imagine that? Like
Let me think.
ADX, context, new, whatever, context, run. Really
Yeah.
fancy. Something like that.
That one I feel like is going too far. Why can't run? Because run is like the entry point to the program.
No, it's not. Main is. Because in main, you would set up your tracing, your login, your file system. Maybe if you go a bit further, you could set up your multi-threading, maybe your Rayon, if you want to like parallel stuff,
Oh,
whatever.
interesting. Yeah.
And then you execute your run, because run does not run the program; it executes the context. It does the math, right?
Yeah.
Again, this kind of thing you could move somewhere else.
Oh, I have this
you
comment here because I would crash a lot and I would
I'd
lose my
say-
stuff. So just because it would crash a lot, I wanted to save every time I wrote something to the line. So you're supposed to do that outside of the loop, but after you quit the program. But you know,
Okay, there's another way to do that, but if I understand correctly. That's output to a program, right?
yeah, that saves all the commands that I put into the program.
Okay. Wait. Oh, you can just use tracing here. You could just trace it like a. You could use tracing trace, right? And you could. I'm not sure about the API here, but you could set up tracing to go into your file instead, not to your console. It totally makes sense.
One thing that's nice about I guess that's fine. Yeah.
I mean, you could like everything like about info, let's say, goes into your console, but everything else, including info, goes into your file. Like tracing allows you to do that.
Yeah.
Because like creating a file just for that, I mean, that's essentially your log, right?
Yeah.
Again, lots of cells could be a bit more cute, I guess.
Yeah.
You don't need those things here.
Wait, let me
Semicolons.
again. Oh yeah.
Like cargo FMT, it will move it like I mean, I guess you can. It'll be like that.
Well, yeah, I had print statements before.
Yeah, it happens when you remove the semicolon here. The same thing can break.
Oh, let me see. Okay, yeah.
Again, same here. If you don't return anything, do you? No, you don't. You do it like that. I mean, you cannot do it like that, but you can add the comma when it's gone, so like that.
Yeah, that's nice.
Yeah, but again, you can replace it with use an error. Even if you were to use println, you would use eprintln. But here, I mean, I would use tracing again
Yeah.
because fancy. Main looks kind of fine. I mean,
Yeah.
yeah, don't need history if you use tracing. You would have to set up tracing here a bit
hmm
more elaborate way. Now I misclicked. Okay. Draw parse.
That's just for testing. That's not used elsewhere.
Oh, if it's for testing, you can actually do this thing. Then it will be available only for testing.
That's cool.
And you can actually move into your test. You just don't mark it with test. So it's like
Yeah.
so this whole block would be like that.
Cool. Oh, I'll be back in a second. I gotta use the restroom. All right. Sorry about that. Back. All right.
I would definitely move them into different tests.
Yeah, I had that originally, but it seemed like it was just like so much code. Like it felt like boilerplate. But I agree because it's super annoying that when you have a bunch of different ones, it doesn't tell you which one failed really. Well, it kind of does.
Yeah.
But.
Yeah, I mean, kind of does. It says the line, right? And then you need to figure out what happened here.
Yeah.
You just scroll on to test. Or, if you prefer this, like how's it called? Table testing, whatever. You could actually add another element to a tuple that would like add a name, right? And then where you create a search here.
Yeah, I could print the name.
The third thing, you could provide a reason. Like it should be like expected, and then you would have a reason, like a next element.
Yeah. Well, one thing that I really need to add with testing is that I need to, especially with match testing, I need to make sure that the rules, like the maps that are populated, do the right thing. So I'm planning to rewrite at least a good portion of that.
Yeah, it makes sense.
Yeah, but up until now, it's pretty much just been figuring out how to make the pattern matcher work, and it seems like I'm not actually done with that, unfortunately.
I see.
How long have you been writing Rust code? Seems like a while.
For a year. For a
Oh,
year, I
damn.
think.
I feel like I've been writing for a year and I'm still writing random stuff.
I mean, I had several years of experience in similar languages.
Mm-hmm.
I was using C++ for 2 years before, and a bit of Java, but not for long.
Are you do you do it professionally? Programming?
C++, yeah.
Oh, nice. What do you do?
Java, well, not really. In C++, it was game dev.
Oh, really? You're a game dev?
I used to be.
Hmm. That's sick.
Really shitty job.
Oh, yeah?
Yeah. I would rather work for some kind of casino or maybe porn website, whatever, man.
That's hilarious, man.
No, man, I'm not joking because salaries are much better.
Oh, yeah. Yeah, game dev I hear doesn't pay as well as yeah.
Yeah. Yeah, I mean, I had a friend of mine that he used to work in a big name company.
Mm-hmm.
Starts with UB, ends with soft. Yeah. So he switched his job to fucking casino.
Damn,
He
that's
started earning like
crazy.
twice as much. Yeah, like gambling, like online gambling. There's
Mm-hmm.
it's not roulette, it's like a slots or whatever. How is it called?
Yeah, yeah, slots. Yeah.
Win or lose,
Where are you from,
that
by the
kind of
way?
thing. I live in Poland.
Oh, Poland. That's right. Yeah.
Yeah.
Nice. All right. I think I might need a. I think I might need to wind down. I've been streaming for 5 hours. I think I need to go get some food. Uh.
Yeah. Bon appetit. Yeah, I've been checking out your comments at the bottom.
Oh yeah. Those are just like notes, you know.
Actually make testing. Next one.
It's kind of. I mean, making an interpreter or interpreted language is kind of an interesting problem because there's so much to do right off the bat that like it's a little overwhelming, and
Yeah.
deciding what to do first is kind of tough.
Yeah. Makes sense. Wait, what is that? What is this I?
Oh, it's just with the test number.
Wait. Oh, yeah, makes sense. But the test number starts with 0, but okay.
Yeah.
I mean, you could just use either, I guess. But whatever. Next time, I guess then.
All right. Yeah. Thanks a lot, dude. You should start streaming. By the way, I would totally watch you streaming making that web crawler.
No, it's boring. Several years ago, actually, not several, I think quite a few years ago, I used to stream CSGO.
Oh, nice.
And and I kind of so I used to stream with the so we were streaming pretty much all day. Like he was streaming for like 6 hours. I was streaming for around 6 hours.
Damn.
Um, yeah, it was kind of big, honestly. At that time, we had like a 40, 50 viewers like all the time.
Oh, that's crazy.
It was like I think it was like 6 years ago, around 6 years. Yeah,
Wow. That's cool. I
yeah.
haven't
It
played
was kind of
CS:GO.
big, like because we got that in like a week or two.
Damn.
It was insanely fast.
Wow.
Yeah.
Yeah. No. I mean, I think I
Like
actually
I think
peaked on.
nowadays I don't think.
Go
Sorry.
ahead. What were you saying?
Yeah, I was saying that I think nowadays it's pretty much not possible to get like a 10 viewers in that Good.
Yeah. I mean, today I think I hit my maximum number of viewers because that guy rated me and I got up to 5. But yeah,
Yeah.
pretty cool. All right, so I have lots of changes I need to make. I think I might start over. I think I might start over because what I've been doing, I don't
What
know if
is
you
it?
saw. So I'm putting all the VODs on YouTube, and so the past couple of days I'm starting from a blank Rust project so that I do the same thing a few times just to learn how things are supposed to go because I feel like if I the repetition helps me learn it.
Yeah.
Um,
Yo, I just noticed you don't need to import your variants.
oh yeah, I think that was probably just automatic. I don't know why that happened. Oh, actually, try deleting that. I feel like an error happens though.
Yeah, there will be an error, but it doesn't matter because what you can do, you can just use
Oh,
counter.
okay, yeah. Oh, because that's an enum. All right, yeah, that makes sense.
Yeah,
All right,
yeah, because it was kind of weird to see board just.
yeah.
Hey, what?
Why do
What
I
are you
need
doing
that?
with these?
I forget why I need those. Oh yeah, I
Dude,
was trying
what
to
is
make this.
going on in
I didn't know how to make this work because if you do A plus
here?
B, it doesn't work. So yeah, if you could resolve that, figure out what I'm supposed to do.
Wait,
Oh, okay.
I was like, what the hell is this?
All right, we need to and then we can do the same for times.
Oh, the times? Is it not mole?
Yeah.
That should be mole. Left one. Oh, A plus B.
Wait. Times B.
Oh, wait, yeah, right. Multiplied. And there should be one more, yeah?
Okay, cool. Wait, is the star times in Rust?
Yeah, yeah,
Okay, yeah.
yeah. Just multiplied, yeah.
Yeah, it calls mole. Okay, cool.
Man. Wait, what is. Oh, yeah, you match the tuple, okay.
Yeah, which is actually wrong because make variadic. You want to be able to provide times with as many arguments as it has in fold, but for now I'm not doing that.
Yeah. You can just do this now. Here.
What? Where'd you do? Hold on. Oh,
See that?
yeah, that's fine.
Yeah. I mean, lots of that stuff. A lot of as eye size casts for some reason.
Well, part we looked at earlier. Part is just sort of a odd one, because part you can do.
Yeah.
I think I have array indexing tests if you want to see how it gets used. Um,
Yeah, I mean, I can guess, but the issue is that array index cannot be negative.
yeah,
It's
right.
U size, it's not I size.
Yeah, I don't know why I needed to do that. I think it was because the conversion from int for some reason.
No idea.
Yeah,
Do
let's.
you even need that anywhere? Oh, maybe you can use the like a square brackets operation in your code. I have no idea. And then you need to transform it somehow into U size. But instead of doing that, you decided to transform every U size into I size. Yeah, and we do
Mm,
it well in reverse.
yeah.
Yeah. Panic. No, how many panics do you have? Well, let me check. Oh god. Yeah, you can just define the like custom error type. Or if you don't want to do that, you can check out anyhow. Yeah,
Yeah.
check out anyhow and this error. Yeah.
Yeah, I remember. I remember seeing those when
It's
people talk about them.
anyhow
Yeah. Let's
and
see.
this error. Oops. those are fine for error handling. Like yeah.
Yeah, it's pretty nice.
This one also has a feature. This one also has a feature. Kind of useful, maybe. Features. Yes. Anyway, till next time.
Yeah. Thanks a lot, dude. I'm gonna get some sleep and stuff. All
Yeah, me
right.
too. It's pretty late here.
Yeah, I bet. All right. Thanks a lot, dude. It was nice meeting you, man.
Hey, you
See
too.
ya.
Bye.
Dude, what a guy, man. That's sick. That was a crazy stream. I'm definitely gonna have to rewrite cas3. But man, we gotta get to the bottom of this thing, dude. Okay, wait. Let me commit these things. Stream changes. Push that. Okay. Let's connect that. Okay. So let me just switch branches and remember where I was at. Wait, what the hell? Oh yeah, no, that's fine. Okay. Where was I? So just get a new match, right? So what was failing? Let me close all these. Oh, all right. So this case is failing. Seems like it's leaving early. All right, I'm gonna go get some food. This is crazy.